about, I threw together a small virtual world here that uses redstone to do logic operations.
I've seen some YouTube videos and stuff where they've made adders and things like that.
Someone made an entire arithmetic unit. Someone made an entire CPU, I think. And it was like totally crazy. Someone made a 3D printer. You can like give it a specification and it will make your object in Minecraft out of blocks.
I think it's on a hard drive as well. That someone made.
Yeah, cool. All right, so we've got cows and chickens and cow. So here's an inverter. It's a NOT gate, and basically you've got switches that you can flip one way or another, and they send a high or a low signal. And I'm mostly using these pistons that go up and down depending on what kind of signal they get. And so if I flip this switch, the piston comes down. If I flip the switch this way, the piston goes up. And I'm indicating on this little sign here, this is the 0 position, this is the 1 position. For the piston, up is 1, down is 0. So I'm putting in a 0, and the piston's outputting a 1, or showing an output of 1.
It's nice, it shows the redstone glowing where it's live.
Yeah, and it glows where it's live. So when I flip this to a 1, I've got a signal going down here. This block's basically an inverter. It turns that 1 into a 0, and so the output piston goes low. That's a simple NOT gate. Sorry, chicken. This is an AND gate. So we have two inputs, A and B. They're both in their 0 position right now, and there's our output piston. If I flip one, nothing happens. If I flip the other, nothing happens. But if I flip them both, then we get an output. And if it's a 0, 1, or a 1, 0, the output's low. But if both inputs are high, then the output's high. So that's an AND gate. Okay? Keep that in mind. Let's look at something very similar. So this is a NOR gate. So right now these are in the 1 position, that's to the left, and the piston's supposed to be giving us the NOR, so it's doing A or B inverted. So if either or both of these are 1, the OR will be 1, the output will be 0, and that's what we're seeing right now. If I flip one of these, it's a 1 ORed with 0 is a 1, the NOR is a 0, so the piston is still low. If I flip this one, so that both of the inputs are 0, then the piston's high. 0 ORed with 0 will be 0, the NOR will be 1. But if I have one of them high, or both, then the piston's low. Make sense so far? Okay.
Do you have all your logic running underground or something?
No, it's all above ground. Well, there's one spot where I have some trenches,
This is
but
the torches.
the torches are just in case it's nighttime.
No, the redstone torches, right?
Those are regular torches. You can make redstone torches. Those are how you make logic gates.
The
But you've got redstone torches using. Oh no, I guess you're just using switches there.
Yeah, so this is a redstone torch. That's how you make a gate. A redstone torch is on top of blocks and you feed.
Did you make all this?
Yeah.
What's that?
All right, so hold your thought on this NOR gate, right? So both inputs are 1, one input's 1, and the output is 0. If both inputs are 0, the output goes high. That's a NOR, right? Okay, blink for a moment and reimagine what you're seeing here. Suppose this is the 0 position and this is the 1 position. Just flip this sign around, so 0 is over here and 1 is over here. So both my inputs are 0, my piston is 0. One input is 0, the output's low. The other input is 0, the output's low. Both inputs are high, the output is high. What is that? That's an AND gate. So what is this? Is it a NOR gate or is it an AND gate? It depends on what you want it to be. It's De Morgan, right? If we simply change this to be something where the inputs are x and y, and we treat them as being the opposite meaning, De Morgan will tell us that the not of this is the same as the AND of x bar bar with y bar bar, which is just xy. So a NOR gate and an AND gate, they're doing the same thing in some sense. We're interpreting the inputs differently, but based on that interpretation, this one device is either doing an AND or it's doing a NOR. And this is a bit of a hint to why we keep seeing these duals popping up in engineering, in computer science, and math, in the universe. We see these things that come together, ANDs and ORs, KVL and KCL, and so on. And at some level, I think the reason we always see these things paired together is because they're actually the same thing. Right? KVL and KCL are actually the same process of analyzing. ANDs and ORs are in some sense actually the same thing. So that's a little hint to why, for me at least, these duals seem to appear so much. Alright, make the weather better.
Waiting for lightning to strike here.
There's usually thunder in the background. I got the sound off. Alright, so what's going on over here? 3 inverters. So this is our favorite. Inverter, inverter, inverter. Something like what we started with when we began talking about sequential circuits. The output of this inverter is a 1, which makes the output of this a 0, which makes the output of this a 1, and since you have a 1 going in here, the output flips to a 0. And it oscillates.
Why is the clock speed so slow?
Because it's Minecraft, and it's Java, and it's running on my laptop. There is a minimum update time for this stuff, and I think you can probably tweak it. You can certainly mod it. But it's actually nice because it lets you do things with this, like make things that do automatic mining for you, or stuff like that. So there's an A-stable circuit. There's 3 inverters with the output coming back in. If you do 1 inverter, it's not enough of a delay to actually make this work. At least I couldn't get it to work, but 3 inverters does. Same thing in 208. If you actually take 1 inverter and connect its output to its input and look at it on a scope, you don't see it oscillating. But if you connect 3 of them, you will see this oscillation. But you need a certain amount of delay. Alright, so there's a stable circuit. Here's an SR latch. The switches are on the other side. So there's my reset input, 0 to the left, 1 to the right. There's my set input, 0 to the left, 1 to the right. And there's, where's my output? There's my output. So right now the output is a 0. If I flip this reset line, nothing seems to happen. But if I flip the set line, my output goes high. And when I bring the set line back to 0, the output stays high. If I flip the reset, it goes low, and when I bring it back to the 0 position, it stays low. So this is the essence of a sequential circuit. My switches are both in the 0 position, and the output is low. Go out for a cup of coffee, come back a few minutes later. The switches are both in the 0 position, but the output is high. So you can't determine the output just from the values of the inputs. You got to know the history. Okay, that's what sequential circuits are all about.
By any chance, is it possible to build some sort of 5x5 timer in here?
Yeah.
Yes.
Oh, there is?
I don't know if anyone's actually implemented a 5x5 style device, because that would get into some analog representations. But you can certainly mimic the things that you can do with a 5x5, a lot of those, definitely. And I think some people who do it, well, the person who built the ALU, they did it by hand. I think some people have done stuff by using mods where they can tell it what they want the system to do, and it'll go ahead and place the blocks for them. I think the ALU is actually done block by block by hand. this, and I'm horribly slow at it. All right, so that's an SR flip-flop, what I've been calling a gate. It depends on which of these have been asserted most recently, tells you what the value of the output will be. And if we turn both of them on the forbidden state, it goes to a 0. So it's reset dominant, which was what we described when we did the analysis. The moon is coming up. It's going to get dark. It's okay. And the sun is going down. We have to find our last
We went back to the beginning.
device. I did. I made a flat world. When you create a Minecraft world, you can tell it to make everything flat, and it's basically featureless because I wanted to build these circuits. But normally it's got mountains and trees and rivers and oceans and all kinds of things, and it's much more interesting to kind of explore.
How long did it take you to make this?
I think I spent about an hour. I was procrastinating. It's like that traffic intersection simulator. I should have been doing something else. All right, so this is the data line, and this is the load line. This is a D latch. And here's the output down here is the piston. I threw a block of grass and dirt on top of it to make it easier to see. So changing the data line does not change the output value. Changing the load line to a 1 causes the data value to go directly to the output. There's an output of 1, there's an output of 0. Okay, when that load line, which is this switch, is 1, the data feeds the output. When the load line drops from a 1 to a 0, that value is locked into the device. When I drop the load line to a 0, my data input was 1, so the output is 1, and now if I change the data line to 0, it doesn't change the output. Okay, the device is locked as long as the load line is 0. Whatever value is in there stays in there. If I raise the load line, it will load the data value in, which is 0 right now, so the output goes to a 0. And now the data line is ignored again. So that's a D latch. And all of these things are just built from combinations of the other devices. So I built a NOR gate. I put 2 of those together, cross-coupled, to make that SR latch. And then I added this input. From a D bit to the SR so we could use a single data line. And
What are you using for inverters in
and it with a load. Inverters are a block of granite with a redstone torch and some redstone coming out, but depending on where you put the torch, you get different kinds of logic. So if you put it on the side, you get one kind of behavior. If you put it on top, you get another kind. And there's, the Minecraft wiki has a section that talks all about redstone logic. And you can see how to make these. These are repeaters. So just like in the real world, a signal that you send out on a wire degrades over distance. Right? It can only travel a certain length. And it's usually not an issue in our lab or inside an integrated circuit. But in Minecraft, the distance is fairly short compared to the scale of these things. So I have these repeaters that basically take whatever value is coming in and pump it back up to its full value and pass it along. And that's what those are. And this is really just a combination of an SR latch, an AND gate, and then the 2 inputs being ANDed and going into the SNR. That's not exactly the right place. You remember it. Question?
No.
All right. So that's my Minecraft demo.
So could you build a better traffic light?
You could. And then cows could like follow the traffic lights, which would be good. I think it would be fairly unpleasant to do, but you could definitely do it. And you can go on YouTube and just look up you know, like Minecraft ALU, Minecraft CPU, Minecraft 3D printer, or just follow the ones on the side. And people have done ridiculous stuff with this. It's totally amazing, totally fabulous.